Parameter of covalent bond. A covalent bond is characterized by different parameter. This parameter help to understand how strong is the bond between the two atoms, what is the distance between them, and what is the shape of the molecule. 5.6.1 Bond angle. The electron which participate in bond formation are present in orbitals. The angle between orbital holding the bonding electron is called bond angle. Both bond angles can be determined experimentally using spectroscopic techniques. Value of bond angle gives an idea about the arrangement of orbit around central atoms and the shape of the molecule. 5.5 Bond angle of some molecules. Water molecule 104 degree 28 minute. Ammonia is bond angle 107 degree. BF3 is 120 degree. Bond enthalpy. The amount of energy required to break 1 mole of bond of one type present between two atoms in the gaseous state is termed as bond enthalpy. For diatomic molecule, the dissociation energy is the same as bond enthalpy. Bond enthalpy for hydrogen molecule is 435.8 kJ per mole. The bond enthalpy is a measure of strength of the bond between two atoms and can be measured experimentally. The nitrogen-nitrogen bond in a nitrogen is stronger than oxygen-oxygen bond in oxygen. Larger is the bond dissociation energy, stronger is the bond in the molecule. For heteronuclear diatomic molecule hydrogen chloride, the bond enthalpy was found to be 431.0 kJ per mole. In case of polyatomic molecule, the bond enthalpy and bond dissociation energy are not identical. Bond enthalpy is the average of the sum of successive bond dissociation energy. For example, dissociation of water, water gas, hydrogen gas, OH gas, delta H1, 502 kJ per mole. Oxygen hydride in gaseous phase Q's hydrogen and oxygen gaseous phase. Delta H is 427 kJ per mole. Average bond enthalpy of OH bond H2A is delta AH is equal to 402 plus 427 upon 2 is 464.5 kJ. In both the above equation, the bond enthalpy is 0 and hydrogen is vocal, but the amount of energy required to break the bond is different. That is, enthalpy of two oxygen hydrogen bond in water are different. This difference arises due to the fact that cleavage of the two OH bonds in water takes place in two steps. In the first step, one OH bond breaks, leaving behind OH radical. Now the electronic environment around oxygen to which hydrogen is attached is different than the around oxygen in water molecule, and this causes a change in the successive bond dissociation energy. Some difference is observed in enthalpy value of OH bond in ethyl alcohol. Oxygen is attached to ethyl groups. Therefore, hydrogen of OH is in different environment than the hydrogen of water. In the same way, the bond enthalpy value of any covalent bond is slightly different for each bond of that kind in a given molecule and also different molecule. The average value of bond enthalpy delta AH are determined from the experimentally measured value of large number of compounds containing a particular bond. Average bond enthalpy data are given in table 5.4. In general, stronger bond implies larger bond enthalpy. Do you know, among diatomic molecules, the bond order and bond enthalpy of nitrogen is highest? Bond order is equal to 3 and bond enthalpy is 946 kJ per mole. Bond enthalpy CH bond 400 to 415 average enthalpy. NH is 319 kJ per mole. OH is 460 to 464 kJ per mole. Carbon is 345 kilojoule per mole. Carbon nitrogen is 290 to 315 kilojoule per mole. Carbon oxygen is 355 to 380 kilojoule per mole. Carbon chlorine is 330 kilojoule per mole. Carbon bromine is 275 kilojoule per mole. Oxygen is 175 to 184 kilojoule per mole. C double bond C is 610 to 630 kilojoule per mole. C double bond triple bond C is 835 kilojoule per mole. C double bond oxygen is 724 to 754 kilojoule per mole. Carbon triple bond nitrogen is 854. Bond enthalpy. Bond length implies the equilibrium distance between a nuclei of two covalently bonded atoms in a molecule. Bond lengths are measured by X-rays and electron diffraction techniques. Table 5.7 Average bonded length for some single, double and triple bond. Type of bond, covalent bond length, picometer. Type of bond, covalent bond length, picometer. OH. Covalent bond is 96. Type of bond is dihydrogen. Covalent bond is 74. Carbon hydrogen. Covalent bond is 107. Fluorine is covalent bond 144. Nitrogen oxygen. Covalent bond 136 picometer. Dichlorine covalent bond is 199 picometer. Carbon oxygen 143 kilojoule per mole. Bromine is 228 kilojoule per mole. Carbon nitrogen 143 kilojoule per mole. Iodine is 267 kilojoule per mole. Carbon is 154 kilojoule per mole. Dinitrogen is 109 kilojoule per mole. C double bond O is 121 kilojoule per mole. Oxygen is 121 kilojoule per mole. Nitrogen double oxygen is 122 kilojoule per mole. Hydrogen chloride is 92 kilojoule per mole. C double bond C is 133 kilojoule per mole. HCl is 127 kilojoule per mole. C double bond N 138 kilojoule per mole. Hydrogen bromide is 141 kilojoule per mole. C triple bond N is 116 kilojoule per mole. Hydrogen iodide is 160 kilojoule per mole. C triple bond C is 120 kilojoule per mole. Each atom of the bonded pair contributes to the bond length. Bond length depends upon the size of atom and multiplicity of bonds. It increases with increase in size of an atom and decreases with increase in multiplicity of bond. It is generally measured in picometer or in Armstrong unit. Armstrong. Alkane is greater than alkene is greater than alkyne. So an alkyne is greater than C single bond C. Carbon single bond is longer and carbon triple bond is shorter. Some typical average bond length of carbon single double and triple bond and other are shown in table 5.4. Bond order. According to the Lewis theory, the bond order is equal to the number of bonds between the two atoms in a molecule. The bond order in hydrogen is 1, 2 and 3 respectively. Isoelectronic molecules and ions have identical bond order. For example, nitrogen, carbon monoxide, nitrogen oxygen, nitrogen monoxide plus each have bond order 3. Fluorine whereas oxygen 2 dioxygen 2 minus has bond order 1. Stability of molecule can be determined by knowing the bond order. As bond order increases, bond enthalpy increases and bond length decreases. Polarity of a covalent bond. Covalent bonds are formed between the two atoms of the same or different element. Thus, covalent bond is formed between atoms of some elements of hydrogen, fluorine, and chlorine, etc. The shared pair of electrons is attracted equally by bond atom and is situated midway between two atoms. Such covalent bond is termed as non-polar covalent bond. HH electron pair at the center. HH non-polar covalent bond. When a covalent bond is formed between two atoms of hydrogen element of different element and have different electronegativity, the shared electron pair does not remain at the center. The electron pair is pulled towards the more electronegative atom, resulting in the suppression of charge. This gives rise to as dipole. The more electronegative atom acquire a partial negative charge, another atom get a partial positive charge. Such a bond is called as polar covalent bond. The example of polar molecule include hydrogen fluorine, hydrogen chlorine, hydrogen fluorine and hydrogen partial positive, fluorine partial negative, hydrogen fluorine polar covalent bond. Fluorine is more electronegative than hydrogen. Therefore, the shared electron pair is more towards fluorine, and the atom acquire partial positive and negative charge respectively. Polarity of covalent bond increase as the difference in the electronegativity between the bonded atom increase. When the difference in electronegativity of combining atom is about 1.7, ionic percentage in the covalent bond is 50%. Can you tell which molecule are polar? Hydrogen iodide, water, hydrogen bromide, bromine, nitrogen, iodine, ammonia.